In this video, we're going to discuss solving quadratic equations by using the square root property of equality. So here's what the square root property of equality says. That's kind of a long title, but all it says is if x squared equals some number k, then x equals the square root of k, or x equals negative square root of k. I'm running out of room here. There we go, negative square root of k. A lot of times when we're in the process of using this property, we'll combine this statement into just this. So that means the same thing as x equals square root of k or x equals negative square root of k. So here's a simple example of this. Say x squared equals 9. We can kind of think about this intuitively and figure out the solutions because we know that 3 squared is 9, so 3 is a solution. And negative 3 squared is also 9 because it's negative 3 times itself, so we would get positive 9. So 3 and negative 3 are the solutions, and if we use this literally, k is 9, so x equals the square root of 9, or x equals negative square root of 9, and square root of 9 is 3. If k is a negative number, then you'll have square root of a negative number, which is non-real, and so you'll need to rewrite those using I. So if it's non-real, we'll put it in that standard form for a complex number. All right, so here's an example. Negative 4x squared plus 3 equals negative 6. So a lot of times there are multiple ways to solve a quadratic equation. There are a lot of times multiple methods you can use. So some of these we're going to do here maybe could have been done by factoring or some other method, but we're going to illustrate the square root method here. So if we want to use the square root method, we're going to want to get x squared by itself. So we're going to subtract 3 from each side. And then we'll need to divide by negative 4. So we get x squared equals 9/4. So now that we have x squared equals a number, we can use our square root property and say, all right, I know then that x is equal to either square root of 9/4 or negative square root of 9/4. A lot of times we think of this as taking the square root of each side of the equation, which is okay to think about it that way as long as we remember that plus or minus on the right, because there are 2 numbers we can square to get that 9/4. And then square root of 9/4 is the same as square root of 9 over square root of 4. And so we have plus or minus 3/2. So 2 solutions, like we get with most quadratics, 3/2 and negative 3/2 are the solutions. Now it doesn't have to be x squared to use this property. So we might have something like this. And the property still applies. So here we would say, all right, that means then x minus 5 is equal to plus or minus square root of 7. And then we would just keep solving for x. So we would need to add 5 to both sides. So again, we get 2 solutions, 5 plus the square root of 7 and 5 minus the square root of 7. It's okay to list them together like this or to list them separately. Let's do one more example here. So here we have x plus 2 squared plus 5 equals 0. So we need to isolate the squared part if we're going to use the square root property. So we'll subtract 5 from each side. And then we'll apply the square root property. So x plus 2 is equal to plus or minus square root of what we have on the other side. And we have now on the right side plus or minus square root of negative 5. So since it's square root of a negative number, it's non-real, which means we need to write it using I instead. So we're going to write it as plus or minus I times the square root of 5. And then we'll finish solving for x. So we'll subtract 2 from each side here. So we get x equals negative 2 plus or minus I times the square root of 5.